By any chance, do you remember the day of your birth? Yes, I'm asking for day of the week, not the date of your birth. Most of us remember the date, month, and year combination, but do we also know the day on which we were born? Don't worry, if you do not know, I have a very interesting mathematical concept to figure out the day of your birth. So, if I am given a combination of date, month, and year, with the help of a mathematical concept, I can easily figure out the day with that combination. So, let's try and figure out how we can approach this type of question when it comes in competitive exams. Yes, you will definitely get a question based on topic called as calendars, wherein you will be given a combination of date, month, and year, and we'll be required to have the day of that combination. Kindly subscribe to our channel in case you are looking to have more notifications from our side as and when we upload the videos. At the same time, if you like this video, please do not forget to click on the like button. Let's see the concept that will take us to the day when a combination of date, month, and year is given to us. So let's look at the magic that we have here, by which we'll be converting a combination of date, month, and year into the given day of the week. For that, I'm going to just put an example. Let's say 15th of August 1947. Now, this is going to be my first question, which is certainly India's independence date. Now, we are going to check which day did that happen. But before that, I'm going to explain you the entire concept of calendars. So let's see how we can do that. I'll start with the very basic. My first point here would be a year comprises of 365 days. I know this is not 365 for all the years because this data comes from the time taken by Earth to go around the sun. And certainly it is 365 1 by 4, which is 1 year. But then, since we ignore this 1 by 4 for 4 years, that is 1 by 4 for the first year, 1 by 4 for the second year, for the third year it is the same, and for the fourth year it is again 1 by 4 until it becomes 1. Which means the actual time taken by Earth to go around the sun was 365 days and 1/4 of it. But for our convenience, we ignored that 1 by 4 every year for 4 years until that 1 by 4, 1 by 4, 1 by 4, and 1 by 4 becomes 1. And this extra 1 gets added to every fourth year to make it a year of 366 days, which is called as leap year. Now, many of you will be able to understand why do we have one extra day in a year which is called as leap year. So, for my convenience, I'm going to name this year as leap year and the other one as ordinary year. So, what I did, I have actually classified years into two categories. One is the ordinary year having 365 days. The other one is a leap year having 366 days. So, this is where my concept starts from. Now, I have a very, very important concept here, which is called as odd days. This is what is the most important thing that we have in calendars. If you understand this concept well, the topic is almost done. Now, what is odd days? This is not the odd from odd and even concept. Here, odd means something different, something extra. You may have heard people saying that I'm feeling odd today, which means they're not feeling normal. So over here, what does that mean? We know that in a week there are 7 days. So we have a week that comprises of 7 days. But what if I say, let's say there are 9 days that I'm talking about. So out of these 9 days, 7 days will be a week. And what will be extra? 2. And this 2 is nothing but my odd days. Let me pick few more examples. Let's say this time I have 50 days. But out of these 50 days, 49 days will comprise of 7 weeks. Because 7, 7, 7, 7, 7, 7. 7 weeks comprises of 49 days. And what am I left with? I'm left with one extra day, which is my odd day. So I can say in 50 days, there's one odd day. Let's take another example. This time I have, let's say, 243 days. Any vague number I'm picking up. Now, how many days that gets converted into complete week? So for that, what I can do is, because this is the bigger number, I'm going to simply divide it by 7 so that I can get the remainder, and that remainder will be my odd day. So 7 threes are 21, 7 fours are 28, and the remainder is 5. That is my odd day in 243 days. So I hope you understood how to calculate odd days. We simply have to divide the number by 7 because a week comprises of 7 days, and whatever is remaining becomes my odd day. Guys, please understand this is going to be a very interesting concept. We are going to convert any given combination of date, month, and year into a respective day. You can try this with your date of birth as well. Fine. So let's understand this now. So if I want to calculate how many odd days do we have in an ordinary year, what have I to do? I have to divide 365 by 7. So what do I get? 7 fives are 35, 1 5 15, 7 twos are 14, remainder is 1. So our ordinary year will have one odd day. How about a leap year then? Leap year comprises of 366 days. When we divide it by 7, I get 2. So far, I have understood that ordinary year has one odd day and leap year has two odd days. Let's understand the literal meaning of this statement. When we say an ordinary year has one odd day and a leap year has two odd day, what does that mean? Assume that there's an ordinary year which starts with Monday, which means 1st of January is a Monday. Now, if I ask you what day will be 31st of December in the same year, I repeat my question. 1st of January of that year is a Monday. What day will be on 31st of December? Now, since I know that there is one odd day when it comes to ordinary year, which means all the 364 days will be converted into weeks. What will be left outside will be one day. And therefore, if the year started with Monday, the 30th of December will be a Sunday in that case. And hence 31st December would be a Monday. So this is what the literal meaning of when I say ordinary year has one odd day and leap year has two odd day. Now let's take it ahead. So we are talking about 1 year, ordinary year being one odd day, leap year having two odd day. What if I ask you how many odd days do we have in 100 years? Now this is a different calculation. This time we are not looking for 1 year. We are looking for 100 years. So what can I do? Can I multiply it with 365 to get number of days? No. Can I multiply it with 366 to get number of days? Absolutely no. Why? Because not every year has 365 or 366 days. There are certain years which will be leap and there are certain years which will be ordinary. Do you agree to this? In a span of 100 years, some of the years will be ordinary and some of them will be leap years. So how do we determine that? By dividing this value by 4, which means there will be 25 leap years and the remaining 75 would be ordinary years. What we did, we divided it by 7, in fact by 4, to understand how many leap and ordinary years do we have. And now I know that every leap year has two odd days. So I can multiply 25 by 2. And every ordinary year has one odd day. So I can multiply 75 by 1. And then I do a total of it, which comes out to be 125 odd days. So far it should be clear. Now 125 odd days. Can you believe that there would be odd days more than 7? I would say no. Why? Because if you look at our examples, when there were 9 days, we divided it by 7 to get 2 odd days. When there were 50 days, we divided it by 7 to get 1 odd day. When there were 243 days, we divided it by 7 to get 5 odd days. Why? Because the moment the number becomes greater than 7, it will form a week. And therefore, it cannot be possible, or it's not possible to have more than 7 days as odd days. So over here also, because we are getting 125, we have to divide it by 7 to get 7 ones are 7, 55, 7 sevens are 49, 6 odd days. That's what my calculation for 100 years is. I would do a quick recap. I said we have to calculate odd days in 100 years. But all the years will not be either ordinary or leap. So we divided the number by 4 to get 25 leap years and 75 ordinary years. Now every leap year has 2 odd day, every ordinary year has 1 odd day. And therefore my total comes out to 125. But 125 is greater than 7, so we divided it by 7 to get 6 odd days. So this is where we have reached. Now there's a twist in the story. What is that twist? I am saying that 100th year, I repeat, 100th year is not a leap year. I'm using a different color for it so that I can explain it to you later on. I'm saying 100th year is not a leap year. Now you would be surprised, because how do we determine whether a year is a leap year or not? We divide the number by 4. If it is perfectly divisible, I repeat, if it is perfectly divisible, the number is called as a leap year. 100 is perfectly divisible, but I'm saying that it is not a leap year. Why it is not a leap year? I'll tell you the reason behind it in some time from now. But at the moment, you just have to remember this, that 100th year is not a leap year. And the moment I say so, this calculation will change. Why? Because according to my calculation, 100th year should be a leap year, and therefore I was getting 25 leap years. But if it is not a leap year, my value for leap years would become 24, and therefore my value for ordinary year will become 76, which means the year which was not leap year will now be an ordinary year, and hence leap year becomes 24, ordinary becomes 76. Again, we'll go with the same calculation. Every leap year has 2 odd days, every ordinary has 1 odd day, and the total comes out to 124 this time. But as I said, odd days cannot be greater than 7, so we divide it by 7 again to get 5 odd days. Wonderful. Which means we cannot have 6 odd days in 100 years, it will be 5 odd days in 100 years. If this calculation is clear to all, we are almost close to the concept that allows us to find out the answer to the question that we have written on the screen, which is 15th of August 1947, and we have to find out the day of the week. So what we have, see, what we are discussing so far is the explanation, or I would say derivation. What is useful for us? I'm just going to write all the statements which will be useful for me while I'll solve a question. And they are: ordinary year, I repeat, ordinary year will have 1 odd day, leap year will have 2 odd day, 100 years, a span of 100 years will have 5 odd days. So these are the only 3 points that I have to remember while I'll solve the question from whatever we have done so far. Now, let me come back to the concept once again. If 100 years have 5 odd days, I'm going to write it again. If 100 years have 5 odd days, then 200 years should have 10 odd days. Similarly, 300 years should have 15 odd days. A simple linear calculation that I'm doing. And also 400 years will have 20 odd days. Now, some of you might think that why is it 10, 15 and 20? Because they are greater than 7, we should be dividing them by 7, which is absolutely right. So over here it will be 3, over here it will be 1, and this will give me 6 odd days. So now if I want to ask you how many odd days do we have in 200 years, your answer would be 3. How many odd days do we have in 300 years? Your answer would be 1. And how many odd days in 400 years? Your answer would not be 6. I'll tell you why. There is one more twist here, and that is 400th year is a leap year. So what I mean by this is, when I said 100th year is not a leap year, 200th year is not a leap year, 300th year is not a leap year, but 400th year is a leap year. Now the question why would be answered in some time from now. So far you just need to remember that it is only the 400th year which is a leap year out of the other century years so far we have discussed, which is 100, 200, 300 and 400. Now, if 400th year is a leap year, my calculation here would change. Instead of 20, it will give me 21. And therefore, when I divide 21 by 7, I would get 0 remainder. And hence I can say 400 years will have 0 odd days. I'm sure there would be some of the viewers who will not be able to understand how come this 20 has become 21. So I'm going to quickly explain this on your screens. From 1 to 100 years, the odd days was 5 for 1 century. From 101 to 200, another century, odd days would be 5. From 201 to 300, another century, odd days would be 5. From 301 to 400. Now, this is different because 400th year is a leap year. And if you remember, if my century year is a leap year, this calculation would be followed. And therefore, my odd days would be 6. Therefore, in 100 years, odd days are 5. In 200 years, it is 10. In 300 years, it is 15. In 400 years, it is 21. And while we divide it by 7, we get 0. So which means my 200 years will have 3 odd days. My 300 years will have 1 odd day. And the most important, which is my 400 years, will have 0 odd days. So these are the 6 statements I have to keep in mind while I solve the question. And I bet on this, every question will be solved based on these 6 statements that we have. Every question of calendars will be solved. Don't worry about these 2 pointers that I have written over here. I'm going to explain them at the later part of this video. But so far, what we have done, I'm going to do a quick recap of what we have discussed so far, which is every year was comprising of 365 days, except for the leap years, which has 366 days. What is the odd day? Odd days are the number of days which remain extra, while all the other days gets converted into complete weeks. How do we calculate it? We divide the number by 7 to get the remainder as odd days. For ordinary year, odd days came out as 1. For leap year, it was 2. For 100 years, when we have to find out number of leap and number of ordinary years, we divided it by 4 to get 25 leap and 75 ordinary years. Every leap year had 2 odd days, every ordinary had 1 odd day, therefore total was 125, but 125 is greater than 7, so we got 6 odd days. Now here came a twist which said 100th year is not a leap year, and therefore this 25 becomes 24 and 75 becomes 76. Upon calculation, I got 124, which upon dividing by 7 got 5 odd days. So ordinary year has 1 odd day, leap year has 2, 100 years have 5 odd days. When 100 has 5, 200 has 10, 300 has 15, 400 has 20. Every number except for 20 was divisible by 7, divided by 7 to get 3, 1 and 6 respectively. So over here 3, 1. But I said 400th year is a leap year, and therefore this 21 becomes, in fact 20 becomes 21, and my odd day for 400 years comes out to be 0. This is what we have done so far. Now let me ask a question. If 400 years have 0 odd days, how many odd days do we have in 500 years? Think on it and you will get 5 odd days. Why? Because 500 is nothing but a combination of 400 plus 100 years, out of which 400 gives me 0 odd days and 5 or 100 gives me 5 odd days. And therefore 500 has 5. What about 600? Undoubtedly 600 will have 3 odd days. Similarly, 400 and 200. 700 will have 1 odd day, 800 will have 0 odd days. So, which means a cycle of 5, 3, 1, 0 gets repeated again and again. And every multiple of 400 years will give me a 0 odd day. So, this is what the concept of calendar is. Now, let's move to the questions. Let's take a question that was there on the earlier screen. The question was 15th of August 1947, and we have to figure out the day for this combination. So what were the important points that we studied so far? The pointers were ordinary year will have 1 odd day. I'm just writing it one more time. Leap year will have 2 odd days. 100 years will have 5 odd days. 200 years will have 3, 300 will have 1, and 400 will have 0. This is what I have studied so far. Also, there's a standard table which we'll be using Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Every day having one corresponding number of odd day. So Monday stands for 1, Tuesday for 2, Wednesday for 3, Thursday for 4, Friday for 5, Saturday for 6, Sunday for 7 or 0. Because having 7 odd days or 0 odd days is one and the same thing. Because when we divide 7 by 7, the number of odd days comes out to be 0. Now let's come to the question and see how easily can we solve this question. So I'm going to break this question into two parts. First part, wherein I will be talking about years. How many years have gone? 1946. Now you may think that why am I writing 1946 instead of 1947? Because 1947 is still ongoing. 15th August is 1947. So I'm going to calculate number of odd days for 1946 years, and then we'll calculate separately for 1947. So 1947 can be broken into 1600 plus 300 plus 46. Why did I do so? Because 1600 is a multiple of 400 and therefore it will have 0 odd days. 300 years will have how many? 1 odd day. So now my question is only on 46 years. Remember, it's a year. Therefore, we can't divide it by 7. So I have to calculate odd days in 46 years. What can I do? I have to divide it by 4 to get number of leap and ordinary years. 4 11s are 44 and the remaining are 35 years. So I get 11 leap years and 35 ordinary years. Every leap year has 2 odd days, every ordinary has 1. This is the same method that we use for 100 years. So 11 multiplied by 2 plus 35, I end up getting 57 odd days. But we know that odd days cannot be greater than 7. So we divide it by 7. 7 eights are 56 and I get 1 odd day. Which means 1600 gives me 0, 300 gives me 1 and 46 years gives me 1. So the total number of odd days in 1946 years is going to be 2. So which means we have completed the past years already. Now let's come to the second step for the question, which is the current year. So current year, I have to reach till 15th of August. January has 31 days. February has 28 days. Now this is depending upon the year that we are calculating for. If 1947 is the year, it is going to be ordinary year. Therefore, February will have 28 days. Had it been a leap year, we would have counted 29 days in February. What about March? March has 31. April has 30. May has 31. June 30. July 31. August 15. Please remember, we have to calculate only till 15th of August. So do a total of it. and you will be getting 227 odd days. Is it possible to have 227 odd days? Absolutely not. So what we do, we divide it by 7 once again. 7 threes are 21, 7 twos are 14, remainder is 3. So from the current year, number of odd days are 3. From the past year, number of odd days were 2. So number of total odd days is 2 plus 3, and that's equal to 5. 5 according to my table is a Friday, and therefore I can say India got independence on a Friday. A very easy and interesting concept. Yep. Let me do a quick recap of this question before we take another question. So the question says 15th August 1947. I started with the previous years. Instead of 1947, I take 1946 because 1947 is the year which is running. So I split 1946 as 1600, 346. Why? Because 1600 is a multiple of 400, therefore would give me 0 odd days. 300 years will have 1 odd day, and therefore it is 1. 46 years, some of them will be leap and some of them would be ordinary. To calculate that, I divided by 4. I got 11 leap year and 35 ordinary years. Every leap year has 2, every ordinary year has 1. Therefore, 11 multiplied by 2 and 35 multiplied by 1 gives me 57. 57 odd days is not possible because it is greater than 7. So I divided by 7 to get 1 odd day. 1 from 46, 1 from 300, 0 from 1600. Therefore, 2 odd days in 1946 years. Now let's come to the current year. I have to go from January to 15th of August. So I wrote all the number of days that we have in respective months. The total was 227 when we divided 227 by 7, because 227 cannot be the odd number of days. I got 3. 3 from the current month and 2 from the previous month. The total was 5, and 5 according to my standard table is a Friday, which means India got independence on a Friday. That's a very frequently asked question. Let's take one more example. Now, this time, my question is 26th of January 1950. Yes, another important day from the history of India, Republic Day. Now, let's do it quickly. I am going to start my question from 1949 because 1950 is still running. I'm going to split it to 1600, 300, and 49. Why? Because 1600 is a multiple of 400. 300, I already know number of odd days is 1. 49 years to get number of leap and number of ordinary years. I get 4 12s are 48 and 37 ordinary. 12 multiplied by 2, 37 multiplied by 1. 24 plus 37 gives me 61. 61 odd days is not possible, therefore I divide it by 7 to get 5 odd days. 5 from here, 1 from here, and 0 from here. Total number of odd days in 1949 years is 6. Let's talk about the current year, January. Now, since I have to go only till 26th of January, therefore my number of odd days are 26. But 26 is greater than 7, which gives me 5 odd days from here. 5 from the current year, 6 from the previous years. 6 plus 5 gives me 11. But 11 is again greater than 7, so divided by 7, I got 4. And 4 in my previous slide was Thursday. So India got Republic on Thursday. That's how easily we can convert a combination of date, month, and year into day for that week. And you can try some of the questions picking up random dates from the calendar, from the history, from the past, from the present, and check whether you're getting the same days or not. Now, let me talk about two of the concepts that I mentioned on my first part of the video, which was 100th year is not a leap year, whereas 400th year is a leap year. Let's understand why that has been the case. So I started discussing this topic by saying that every year has 365 days. Then I corrected myself by saying that every year has 365 1 by 4 days. Now I am going to tell you the truth that this is not the correct figure. This is an approximation. So the time taken by Earth to go around the sun is 365 days, 5 hours, close to 48 minutes, and 25 seconds. But for our convenience, we assumed this value as 365 days. And because this was one fourth of a day means 6 hours. So this is the actual value and this is the assumed value. Now you can see there's a difference between these two. When there is a difference between the exact value and an approximate value, we call it as error. And this error over here comes down to approximately 11 minutes. So which means every year we were counting 11 minutes more. So for a year, the error was 11 minutes. But when we talk about 100 years, the error approximately, cumulatively, it became equal to somewhere close to 19 hours. Which means we counted for 19 hours more than the actual value. And therefore, to compensate this 19 hours, we removed a day from 100th year to make it a ordinary year. That's the reason why 100th year is not called as a leap year. So what happened? The error which was supposed to be 11 minutes is now, because we have removed a day, is now close to minus 5 hours in 100 years. But this is again for 100 years. What if the calculation is for 400 years? This error will become 4 times because in 100 years it was minus 5 hours. In 400 years it will close to minus 20 hours. Now, to compensate on this error, we added a day to 400th year, thereby making it a leap year. And that's where the error now becomes equal to somewhere around 4 hours. So the error which was supposed to be of 11 minutes in a year, which was supposed to be around 19 hours in 100 years, which was supposed to be around minus 20 hours in 400 years, is just 4 hours in 400 years now. And that's the reason why 100th is not a leap year, whereas 400th year is a leap year. Got it? Now, there is one more variety of question that we have in calendars. Let's look at that. So there's a question on your screen which says, if January 1st, 2000 is Monday, what day will be on January 1st, 2006? Now, what information will be useful over here is that ordinary year. I'm just going to write that information once again. Ordinary year has one odd day. Leap year has two odd day, and the standard table that we were using: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, with their respective number of odd days. This is what we need while we solve a question which is on your screen. So now let's see. So we have to do one thing. We are going to move from 2000 to 2001, 2002, 2003, 2004, 2005, and 2006. This is what we are looking to move from 2000 to 2006. Now I know 2000 is a leap year, therefore number of odd days would be 2. 2001 is the ordinary year, odd days 1, odd days 1, odd days 1. 2004 is a leap year, odd days 2, odd days 1, and odd days 1. Okay, so I've done primary calculation. Now, one thing to notice here is month remains the same, date remains the same. So we have to move from 2000 to 2006. That's what my movement is. Now, so from here to 2006, what will be my additive values? 2000 will have two odd days, 2001 will have one odd day, 2002 will have one odd day, 2003 one odd day, 2004 two odd days, 2005 one odd day, and now we reach 2006. I am not going to count this odd day. I'll tell you the reason in few minutes from now. So from 2000 to 2006, I have counted only number of odd days till 2005. Let's see what the total is. 2 plus 1 plus 1 plus 1 plus 2 plus 1. How many? 2 plus 3, 5, 5 plus 3, 8. 8 odd days. But that means how many odd days do we have? 1. So if this was Monday, if I have to add 1, this will become from Monday to Tuesday. And that's my answer to the question. Can you believe this? This is how simple it is. So what we did, we traversed from 2000 to 2006. We counted for the number of odd days. We added it, or we shifted our existing day to that many numbers, and we reached to the answer. Now there are two things that you have to notice here. Number one, this question has nothing to do with the previous category of question. You can't go ahead and calculate 1st January 2006 directly. You can't calculate a day for this combination. You should not be doing that. Why? Because this is a question which is based on reference. So if this is true, then what is the day on January 1st, 2006? So we should not adopt the first, or we should not adopt, or we should not apply the same concept that we used in the previous question over here. That's number one. Number two, now why did we not calculate it, or we counted odd days from 2006? Let me tell you a wonderful reason around it, and this is a very important part. We only count that year, I repeat, we only count that year for which we are traversing the February month. I repeat, when we are traversing February for a particular year, then only we count the number of odd days for that year. Now let's see what happened. From 2000 to 2006, this was 1st of January, and we have to reach to 1st of January here as well. So are we going to traverse through the February month of 2006? We are not, because we reached to 1st of January and I got my answer. So I'm not going to traverse through the February month of 2006, and therefore I did not count it for the number of odd days in 2006. Whereas for all these years, we did traverse through the February month while we were moving ahead. Let's take one more example for better understanding. Once again, this time the question says, or let me write those pointers once again: ordinary year, one odd day. By now, you should be able to remember them. Leap year 2, 100 years 5, 200 is 3, 300 is 1, and 400 and multiples of 400 have 0. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. It's a wonderful concept, guys. This is something you may not have studied during your school days. Now let's come back to the question. So here it is, 1st of January 1994 is a Friday. What day was on January 1st, 1988? Now this time we are going back. So let's see, we have to traverse 88, 89, 90, 91, 92, 93, and 94. Now we started from 94 and we have to travel all the way to 88. So first of all, my objective is to find out the number of odd days here. 88 has two odd days, 89 has one, 90 has one, 91 has one, 92 has two, 93 has one, and 94 must be having one odd day. Now let's see what are we doing. So we are traversing backwards here. So we start from 1st of January 1994 and we go back, which means I am not traversing the February month for 94. So I'm not going to count the number of odd days of 94, which means I have to count this, 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 this. And because we are going in the backward direction, please understand. So I'm traversing from December to January. So I'm going in the backward direction. And therefore, the February for 2000, in fact, 1988 is taken into consideration. So we are going to count this number of odd days as well. So how many odd days do we have? 2 plus 1 plus 1 plus 1 plus 2 plus 1. Let's see what the total is. 2 plus 3, 5, 5 plus 3, 8 once again. 8 is greater than 7, so we get 1. So we have to go back by one place. So if 1994, 1st January is a Friday, we have to go back by one spot, and therefore 1st January 1988 would have been a Thursday in this question. So this is how easily we can calculate the question. Please understand these are the two major variety of problems that we get in most of the competitive exams when it comes to calendars. Let's take one more question because people usually ask me this question, that what if the month and the date also varies? So far we were only changing the year. What if the month and the date also varies? So again, I'm going to mark all the important inputs here. Ordinary year 1, leap year as 2, 100 years 5, 200 years 3, 300 years 1, and I'm just doing it for the sake of doing it, else I am sure that by now you would be ready with the numbers. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, and the values are 1, 2, 3, 4, 5, 6, 7 oblique 0. Now let's come to the question. So what are we traversing for? We are going from 44, 45, 46, 47, 48, 49, and 50. Yep. Now let's quickly mark the number of odd days for these years. 44 is a leap year. 45 is not, 46 is not, 47 is not, 48 is, 49 is not, 50 is not. Okay, so what's easy now is from 44 to 50, this is 1st of January, remember. I can easily move from 44 to 50 for 1st of January because that's what I have done so far. Yeah. In the previous question, we have done this variety very easily. Now, I am not going to count this because I am not traversing February while I am reaching 1st of January. I know I have to go till March, but so far I am not traversing through February and hence I'm not going to count the number of odd days for 1950. So what am I left with? I am left with 2 plus 1 3 plus 1 4 plus 1 5 plus 2 7 plus 1 8. Bingo, it's 8 once again. Anyways, so 8 till 1st of January. Now remember, the question is not complete yet. So from 1st of January, I have to reach till 1st of March, which means I'm still left with 30 days of January. Why 30? Because I've already counted for 1st of January. February will have 28 days and March will have 1 day, which is 1st of March. So how many more days now? It gives me 59 more days. So 59 odd days to reach from 1st of January to 1st of March, which means my total number of odd days would be 59 plus 8, which I calculated earlier. So the total gives me 67. But 67 cannot be possible because it's greater than 7. So I divide it by 7 to get 4 number of odd days in final. Which means if this was a Wednesday, I have to move 4 places. 1, 2, 3, and 4. And that's it. I got my answer for this question. It is going to be a Sunday. So I hope you are clear with this as well now. If suppose along with the year, the date and the month also varies. So what should we do? We should traverse to the same date first of all, and then from there we can traverse to the date which is given in the question. So these are the few varieties of questions that we have in calendars. And most likely in an exam that comes from placement papers, you will see these questions for sure. I hope you like the video, and in fact you have more than what you were knowing so far. You have understood the concept. Thank you.
If you like this video, subscribe to our YouTube channel and hit the bell icon to never miss a video from upGrad.